Hello everyone, welcome to this video. Today we will hear from Jayanth Kumar, who completed his internship, the POT, Professional Occupational Training Program, associated with the US-based individual while working in India at Object Automation. During his internship, he contributed to uh, the development of open source custom processor. So let's explore his journey, achievements, and the valuable experience he gained through his unique opportunity. Let's hear from him.
A lot of folks uses computers every day, but very few of them know what is inside them and how they are functioning. So some people go a step further and build the software systems, but very few people sit down and design their own processors from the scratch, boot Linux on that, and run AI workloads across a cluster they built by themselves. So that's exactly what we have done at Object Automations, and I am very fortunate to be part of that journey. So my name is Jayanth, and I worked at Object Automations as a hardware engineer from February to December 2025. It was a great experience. Honestly, like my background is completely from commercial EDA tool usage and building the physical design flows and doing a lot of back end work of chip design. But this is kind of completely new, whatever I have done at Object Automations. Like I've explored a lot of things about the open source ecosystem, and it completely changed my way of building a chip. The vision of object automations was very simple. Like, can we build the chips and AI infrastructure open and accessible to people or not? So right now, I feel most of the uh, like most part of the world is uh, depends on proprietary hardware from handful of companies, I would say. So we wanted to change that. We believed we like you could build a fully open stack infrastructure, like open instruction set, open RTL, open software, open EDA tool, and eventually run AI on the silicon that designed by yourself. So that's where the microwatt comes into the picture. So microwatt is an open source processor which was built by IBM and Open Power Foundation. And what we are doing at Object Automations was taking that as a foundation and enhancing it. Like, we are adding a lot of low power instructions to that existing processor. So even the instructions are from open source a platform called PowerISA. So we are using like 3.0 version of the instruction set architecture. And so yeah, we weren't just using existing design. We are actively contributing to the design and evolving it. So we started at very bottom, like what are the modules available for the microwatt processor and what are the features it has. And then, like, we have added our own instructions, low power instructions to the existing RTL, and we have synthesized the same RTL code using a tool, open source tool called Yasis. So that is a part of Open Road EDA infrastructure, and like, we have used a open source PDK process design kit called Skywater 130 nanometer node, and then we were like uh, integrated all of our RTL module and constraints and the technology into the open road infrastructure, and we ran from right from RTL to GDS generation. Once the processor was stable, the next thing we have to do is we have to boot a lightweight Linux OS on top of the CPU or the processor which we designed. So basically, it involves like generating a bitstream file of the same processor and flashing that file on top of an FPGA board, so that the board itself act as a processor, and it will act as a simple small computer. So this process wasn't so smooth actually. So we have done a lot of workaround and a lot of debugging uh, things, I would say. So like after a lot of work, then we were able to go through all of these things, and we were able to get the login prompt uh, of Linux on the screen. So that's where like we realized that we have built our own computer. The next step involves scale to a cluster. So after getting one node running, like we asked ourselves that what if one isn't enough? Then we were like, so we built a 5 node FPGA cluster. Each node was running Linux on the microwatt based processor, which we designed, and we connected them over Ethernet and set up IP addressing, routing, and NAT through a head node. So basically, we created a small data center, except every mission in it was running on a processor we built from RTL.